Lesson 8, lines in gradient intercept form. We've looked at these a little bit already, so this is in the form y equals mx plus c, where m represents the gradient and c is the y-intercept. So you might get pretty straightforward questions like 1a and b here, where it says state the gradient. So for y equals 2x plus 9, the gradient is simply 2. And for part b here, y equals negative 3x, the gradient is negative 3. So it's always the coefficient of x, the number that is being multiplied by x, that is your gradient for linear equations. Question 2, we're deciding if the point negative 2, 4 is on the line with the given rules. Here all we need to do is sub in our x and y values and see if they equal each other. So in this case we've got 4 equals 2 times negative 2 plus 10, x value going there, y value here of course, and that gives us negative 4 plus 10. 4 equals 6 there. So that is not true. Negative 2 and 4 is not a point on the equation y equals 2x plus 10. Let's have a look at this one. So this time subbing in negative 2 again for x, and we end up with negative 1 technically by negative 2. It's positive 2. 4 equals 4. So yes, the point negative 2 and 4 does lie on the equation y equals negative x plus 2. So yeah, you're just subbing in your values, and if it comes out to be, in this case, 4 equals 4, then it is true, that point does lie on those lines. If it doesn't work, so 4 does not equal negative 6, it's not true, that point does not lie on those lines. You might even have something like this, where write a rule for the following equation. We're being told that our gradient is 2, so we're going to write y equals 2x, and our c value is our y-intercept, so in this case positive 3. Same thing here, y equals negative 4x plus whatever our y-intercept is, which is 7. You might get some questions like this where you need to rearrange to make y the subject, meaning making it y equals. Here I'm going to add x to both sides, leaving me with y equals 3 plus x, or you could write it as x plus 3, doesn't really matter. Here I'm going to add 3x to both sides, and then divide both sides by 3. And remember, this is for both terms there, so 3x divided by 3, 3 divided by 3 is 1, so we're just left with x, and then 9 divided by 3 is 3, so just be careful with those. Same here, we're going to subtract 2x across this time, leaving me with y equals negative 2x. So question 5 here, find the gradient and y-intercept and sketch. So you do need to rearrange these so that they are in the form y equals to find the gradient. So in this case we could subtract x from both sides here, giving us negative y equals 6 minus x, but we really need it in y equals, and to move that negative across it's like multiplying by negative 1, and that's every term. So we end up with negative 6 plus x, remembering that there's a little 1 here. So the gradient is 1 for this equation, and the y-intercept is negative 6. So negative, we don't have it on the grid here, so we're down here, and the gradient being 1, why is it going all strange? Means that it's going right 1 every time it goes up 1, so we're following a line like this. So we've gone off the grid a little bit there, but basically the key is to rearrange them so that each equation is in the form y equals whatever it is, the subject is y. In this case we're going to do a similar thing, so now I've got 8 minus x as I've subtracted x from both sides, and then I'm dividing both sides by negative 2. And remember, this is for both terms, so 8 divided by negative 2 becomes negative 4. and we end up with positive x over 2. So the gradient here, it's the same as a 1 being at the top here. The gradient equals a half, and the y-intercept is -4. So when the gradient's a half, it means that it is that's rise over run, so it's rising 1 unit for every 2 units that it runs. So we would go from there to there, so running 2 and then rising 1 to there. And it's going to have a shape like that, but obviously a straight line. Use rulers where you can. And you might want to state that our y-intercept is 0 and -4. Have a look at these questions. It's question 12 from the textbook. It's part of the unit outline. They're just some slightly challenging questions in rearranging them to find it as y equals and calculating what the gradient is. So just have a bit of a look at those. I won't go through them in detail now, but certainly worth practicing before the test.